time and energy commutator. Time operator T with a hat equals T. Energy operator E with a hat equals I h bar partial derivative with respect to t. In classical mechanics, time times energy equals energy times time. Therefore, we say T and E commute. In quantum mechanics, T operator times E operator equals E operator times T operator. Is that true? Does T operator and E operator commute? That's what we're going to show. This is how we write the commutator. This is time operator and energy operator, and the whole thing is product commutative. Multiply both sides of the equation with psi. Psi is a dummy function because the operators are meaningless on their own. In order for them to be functionable, you have to act on a function. That's why it's multiplied by a psi. So now I have replaced the operators with their values. So that's the E value, and that's E, and that's T. So what I've done now is taken out the common factor here and there. That's iota h bar, and then multiply everything by psi. So psi times that and psi times that, and that's why I get partial derivative with respect to t, and then times the psi, and partial derivative with respect to t times the time and psi. Just so you know, I is pronounced iota and it's root minus 1. It's a complex number, and h bar is equal to h over 2 pi, which is called reduced Planck constant. So now we have a product here, and if you have a product and you're differentiating a product where u is a function of t and v is a function of t, derivative of the product is written as u dv dt plus v du dt. So all I've done now is replace u and v with t and psi, and so I've got that here. After replacing that, this one is 1 because they cancel out, so I just get psi, and I'm going to take that, I'm going to put it over there. So now I've replaced that with this here. So I've replaced that with that. You can see there's a minus there, and if I open the bracket here, I will multiply all that by minus. So now I've opened out the bracket here, and you can see that's minus t partial derivative of psi with respect to t. You can see that and that cancel out because they're the same thing, and I'm left with minus psi because minus times plus is minus. So now that cancels that, and this is minus phi multiplied by I h bar. We get that. Now the phi here, we cancel that phi. So this is what we get with time operator and energy operator commutator equals to minus I h bar, and that's not equal to 0. Therefore, time operator and energy operator do not commute. So what I meant is time operator times energy operator is not equal to energy operator times time operator. So what about energy operator and time operator commutator? Well, what we do is expand that, and we get that. And then if I take minus out, this will become minus, that will become plus. If I rearrange that, write down the plus first, so I get this. And what does that remind us? It reminds us of that. And so then I get because we know that is that. And so we get minus I h bar. And therefore minus times minus is plus, so you get I h bar. So the reverse is I h bar. Again, that is not equal to 0. And that shows that energy operator and time operator do not commute.